Okay, today we'll be talking about strings and text files within Python. We'll dive into how do we access individual characters within a string, how do we utilize substrings or retrieve substrings from within said string, how do we convert items within a string to a different representation. We'll look at methods that are made available to us via strings, and then we'll dive into interacting with text files from the context of how do we make them, how do we alter them, delete them, and just largely interacting with them. Okay, so with that, let's get started. The first thing I'm going to do is I'm going to declare a variable called sentence, and I'm going to put in there a string saying my first name is Nando, my last name is Tomlinson. All right, and now that I have that variable, I have an instantiation of a string being held there. And if there was ever any misunderstanding, or if I wanted to verify it, we recognize that we can use type, and within type we can feed it whatever data set we wanted to feed it, so it can tell us what we are working with. Now that I have this, there's a couple of things that are made available to me. With a string instantiation, there's a number of methods, and as we would call methods or actions that we can utilize. So for us to get a listing of those, we could do dir, and we can run dir on our instantiation. Now, with all of those items being made available to me, sometimes it can be a little overwhelming, just not knowing what they are. So as I find something of interest, I'm able to utilize help and understand it a little bit more. I could also use the internet as well. Now, sometimes there'll be one or two methods made available. Other times there's 40, 50. In the instance of strings, we have, let's see, we have 78 items that are made available to us. And as I start off with my string that I have in a variable called sentence, I notice that certain letters are capitalized, and that's based upon my own doing when I declared this string. So what I could do if I wanted to convert this to uppercase is, looking at my methods made available to me, I see that there is a method called upper. For me to verify that upper, or get a little bit more information into what upper provides, I could come in and do help, and I can input my instantiation of my string, and then I could call upon that method, and it tells me that the upper method is part of built-ins, and it returns a copy of the string converted to uppercase. So that seems like exactly what I want, and with that I'm going to go ahead and utilize it, and in doing so, notice that my string is now returned to me in uppercase. Now, I don't have to have an instantiation of this string within a variable to utilize this. I could also declare or call upon a string without declaration and utilize the methods that are made available to it as well. Now, with that, let's say I wanted to turn my string to lowercase. Well, looking at my methods list, I see that there is a lower. So I would have ran help on it to better understand it. But with that, I'm now going to print it out, and I'll do lower. Awesome. So that indeed does what I want it to do. Now, if I wanted to do a check in the sense of, hey, is everything in here an alphabet character? All right, I could do is alpha, and this is going to return a Boolean logic for me in the sense of true, false. Now, we see that we're returned with false because from the perspective of is alpha, we have spaces, we have a period, so we have a number of things that enable or really set this to come back as false. Now, let's run it on something else that we know does not have those items in there. In this case, I'll do Nando, I'll do is alpha, and it comes back with true. Awesome. So that is indeed what we're looking for. Now, if we're concerned with being able to check for if there's digits or ints only within a particular item set, we could do is digit. And is digit is going to return Boolean value as well. So is digit. Awesome. So it comes back as false, but we already knew that. Now, let's say we wanted to do another one just to be sure here. I'll put in 1, 2, 3, 4. I'll do is digit. And although it's a string instantiation, we have within our string what the human eye would call numbers or ints. So it returns true for us. Now, let's say within my variable of sentence, notice how I have the M up front capitalized. I have N in Nando capitalized, my M there, my T there. Now let's say I wanted to invert them where those items become lowercase and everything else becomes uppercase. Well, I could utilize the swap case method and I would be able to do that. And let's say I want to turn my string into a title, if you will. Well, we could do that as well, and we would utilize the title method. So largely speaking, titles have the first letter in each word capitalized, and when I utilize the title method, we see that's what happened to my text there. Now, let's say I wanted to count the number of times something was shown within my string. Well, I would utilize the count method. And what's interesting about the count method is, well, let's go look at the help file on it. The count method allows me to specify not only a substring to look for, but we can say within a particular area with our start and end, but we notice that it wants an int, right? Or what it returns rather, excuse me, what it returns rather is an int. Okay, so let's do this. What we're going to do is we're going to come in and I'm going to print sentence. That's my variable containing my my string with my name, and I'm going to utilize count, and I'm going to look for how many times is listed within that string. Okay, so we see that we're returning 2, and when we look back at our variable, we see that there are indeed 2 instances of is. Now, what if I ran this again, and in this case, I change the lowercase I to a capital I? Well, that's interesting. We already knew that Python is very case sensitive in that nature, so it's really no surprise that that didn't come back with anything. But you may also be wondering, well, if we're up here changing it to upper and we're changing it to lower and we're also making it a title and swapping case, why is it that sentence is never changing? Well, in that case, we're not affecting the sentence variable as we know it. We're just taking what sentence is holding and changing that. But sentence itself is never ever changing. Not in the form and fashion in which we're doing it. If we want to actually change it, we would need to specify something like sentence, and then we could do sentence dot title. And now when we look at sentence, we notice that we've taken the instantiation of sentence, made it a title, and where that output has rendered, we have now stored it back as sentence. Awesome. Now, I'm going to go back and I'm going to change it back to how we initially had it so we can continue on. Okay, so as we continue on with this, we now have the ability not only to count the number of items or the number of instances an item is shown within a string, but we could also replace them. Now, this is what's going to really make Python somewhat great. It's really, really great to begin with, but it's one of those additional things that really we're benefiting from within the language. And as we go and do this, it would look something like so. We'd come in and we'd have our instantiation, which we do, and our instantiation being a sentence. I'm then going to call upon the replace method, and the replace method is going to require that I feed it a old item and a new item. Okay, cool. So within my variable of my first name is Nando, my last name is Tomlinson, I want to replace Nando with Fernando. Okay, so when we do this, it returns to the string, to the screen as that. But what's really still being held in sentence is the originating stuff. So if we want to actually save that, much like we did a minute ago, we're going to have that change happen, and then we're going to either overwrite the variable in which we started with, or we're going to declare a new one. In this case, I'm going to declare a new one that I'll call new sentence. So now when I look at new sentence, we have my first name is Fernando, my last name is Tomlinson. Awesome. So let's look at trying to find or really pulling out indexes within a actual string. So if we did sentence and then understanding that indexes start with 0, the first item would be M, and that's going to be at index 0. The second item, which would be index 1, would be my. The third item, which would be index 2, would be that empty string. Now, what if I didn't want to go down the line like we're doing now, just pulling out individual indexes? Instead, I want to be able to look for something, and then I want it to return to me what is the index of that item. So let's do that. I'm going to look for name. And what we'll do is we'll do sentence.find, and then we'll specify the item that we're looking for. In this case, we're going to look for name. We'll close it up, and it tells me that it's going to start at index 9. Okay, well, if I didn't believe it, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's making me a believer. And I could have also just went and looked at the 9th index, which would be that N, again highlighting the start point. You will see that it only returns the first match, and not every match. this is shown as we see name was returned, but we don't see this instance of name being returned. Now, we could also say, hey, if we want to return more than one instantiation of this, then there's a regex module that we don't talk about in this video that will allow us to get after it. Okay, so let's say we wanted to find, again, find is going to allow us to find the first instance. Let's say we want to start from the back and really find the last instance. Well, there is an R find in which we could utilize that. So we'll do R find, we'll come in, we'll specify name again, and in this case it tells us it starts at the 32nd index. Again, find is going to find the first instance, R find is going to find the last instance. If we want to do multiples finding of that same item, we would want to use the RE module. Now, let's say we're slightly off in what we're looking for. Here, we'll look for names, and we notice that we're returned with a -1. That -1 indicates to us that we have no hits within our string. So anytime we're returned with that, that's a good indicator, or that is the indicator that there were no matches. Okay. Let's say we wanted to get into what a string ends with or begins with. We can utilize the ends with method, and the ends with method allows us to feed in the item that we're trying to see if the string ends with. So in this case, I'll look to see if it ends with a period. I'll put my other parentheses there, and it tells me no, it doesn't end with a period. Okay, well, let's change our search string around a little bit and see if we can indeed have it match. So we recognize that our string does not end with a period. I forgot that off of there. So we'll do a n. Forgot my in parentheses again. And in this case, it tells us it does indeed end with a an n. Now, let's say we want to see if it starts with something particular. Well, there's something that we can use for that as well, and it's going to be starts with. So I'll look to see if it starts with a lowercase m. And what do we get? We get a false back. And we recognize that is the case because it starts with an M, but that M is uppercase. So let's go in here. Let's have uppercase, and it comes back and it tells us, yes, it is true. It starts with a uppercase M. Let's say we wanted to strip off white space, either leading or ending white space. Well, we could utilize the strip method. And the strip method essentially is just going to remove, like I said, that leading or ending white space. Now, we don't have any in our instantiation here, but let's develop or type in something that does. So I'm going to put a space here so I have some white space, and I'll say Nando. I'll do another space, and I'll do a quote, and then I'll wrap it up. Right before wrapping it up, I'll go in and I'll say strip, and I'll do open and close parent. Now, this is going to strip that leading and ending white space. The ending white space we won't really see because we don't have anything to really base our visual off of. But we do notice that the leading white space is definitely gone. And if we wanted to see it in action without the strip method, we see the difference here. This one still has that space up front, no strip. This one has the space up front with strip, and we know this strip takes care of it for us. Now, let's say we wanted to strip out something else within there. Let's say a particular character or a series of characters. All right, so strip doesn't necessarily just do one character. It can do a subset of characters. So we'll call upon our sentence again. We'll do strip. We'll say my space, and then we'll close it up. So notice how we've gotten rid of the my and space within our sentence. Okay, now we could also compound these or nest them, if you will. And the way we'll do that is right off of our previous one before our ending parentheses, we'll do another dot, and then we'll dial into the stripe or strip method once again. And in this case, we're going to get rid of the n, all right, at the end. Well, let me back up. So strip is going to remove leading and ending characters that are supplied. In this case, my space is only at the beginning, so that's going to get removed. We're going to do strip again, and it's going to look to remove the leading and ending in. Okay, so since we have a leading in, we have an ending in, that should be removed as well. Oh, I'm sorry. We don't have a leading in. I didn't take in consideration first. We do have a ending in, and that is removed. But you know what? Let's go ahead and get rid of first as well, so we can see it get rid of both. So I'll utilize the previous syntax I had before, and on top of get rid of my, I'll get rid of my space first, and then another space, and then I'll get rid of the leading and ending in. Okay, so awesome. Let's walk through this again. Sentence, which is my first name is Nando, my last name is Tomlinson, and then we utilize the strip method. The strip method removes the characters that are shown if they're leading the string with it or they end the string with it. In this case, my first, with two spaces in there, leads my string with that. So that was removed. Once that was removed, I then had name is Nando Tomlinson. Sorry, name is Nando. My last name is Tomlinson. And since that was now my string, I had a second strip method applied that removed the leading and ending in. So the in up front was gone, and then the in the rear was gone as well. So we can continuously compound these together. And it's not necessarily, well, it has to be strip and then another strip. We can do a series of different methods together. That's one of the things that makes Python so powerful. Let's look at it from this perspective, where we don't even utilize a variable. I'm going to have ABC123. I'll have 321 CBA, which is that string forward and then backwards. And within there, I'm going to utilize strip, and what will strip is A and B. So what do we get? Again, we have the leading AB taken. That's interesting. We also have the rear AB taken, although it is in reverse. So really we're getting rid of not only the instantiation or instance of AB together, but any instance of it at the rear or the beginning. Now let's take this same thing, and in this case we'll slightly change it a little bit. And when I mean slightly change it, we'll go in here and we'll do CAB for 5, and I'll come in here and I'll just get rid of AB5. So now let's run it. So looking at this output, we see AB was removed. Our string starts with AB, so that makes sense. We notice that 5 was removed. Our string ends with 5, does not start with 5, so that was removed. But the AB here wasn't removed. Well, that's because these characters need to be concurrent. So let's run this again, and this time let's get rid of AB for 5. So we'll notice the AB up front will get removed. We'll notice the AB for 5 in the rear will be removed as well. So although these characters just need to be instances of them happening, it needs to be one after the other. It didn't matter here that it was AB and then BA here, because it was read forward and backwards. So strip is very useful for us as we're manipulating our data and we want to be able to adjust it for our own needs. Now, we could also join items together. So I'm going to declare a variable that I'm going to call first, and in there I'm going to put a string of John. I'll also declare a variable called last, and in there I'll declare a variable of Doe. And when I print out first, I'll get the whole string. But let's say we wanted to kind of chop this up a little bit. Well, we could do first, and we recognize that index 0 of our string is going to be a J. Awesome. Let's run this again, because we're going to essentially try to return J.doe. So for us to do that, we're going to slice off the first character, which is index 0. That's going to be a J. We're then going to concatenate it with a empty string dot, and then we're going to utilize the join method. And the item that we're going to join together is going to be the content of the variable last. And when we do that, we get J.doe. Awesome. So first, with 0 in brackets, that's going to return J. We have an empty string, and we're utilizing the join with the variable of last. Okay, so if we try to utilize join from another fashion, where we specify first and then our index of 0, and then immediately try to go into join with last, our results are much different. So we have the first letter, which is at index 0 of J. So we see that's being done twice. And then we have D-O-E. So when we utilize join in this fashion, it essentially takes every character within last and separates it with what we're feeding it here. This is why we would utilize the empty string and just concatenate it together, because we're essentially joining an empty string with last. That allows us to have DOE straight out without having doe separated by J's in this case. Okay, so now that we can utilize join from that manner, how about we just concatenate our last name here? So we'll do print first with 0 for the index, and then we'll just concatenate last. And that gives us the same thing. So what we're highlighting here is join isn't necessarily something we always need, but we can definitely manipulate strings when there's nothing else available for us. It's just that in this example, we can do it from two different manners. Now, let's go a little bit deeper, if you will. And here, what we'll do is we'll declare a variable called num, and we'll feed it 1, 2, 3. We'll do a space 3, 4, 5, 6. We'll do a series of spaces, and we'll feed it 7, 8, 9, and then we'll close it up. I guess it would help if I actually utilize the assignment operator as opposed to a negative connotation here. All right, so let's go back. Let's get rid of that. Okay, cool. So now we've declared num with that string of numbers. And let's say we now want to split. We can do num.split. And we can say, hey, let's just split on essentially our white space, if you will. And what we get back is 3 individual items. And those 3 individual items are part of a list. Now, looking at this, I would know because those are enclosed by brackets, but let's do a type on it. So we could do type num, not split, open, close, and then we'll close again. And it tells us it's a list. So I'm going to run this a little bit differently. And then this time I'm going to create a new variable. The new variable that I'm going to create is going to be num1. And when I do type on num1, I see the same thing. Now, what happens if I just try to get the first index, i.e. index 0, rather, of num1? We see the string of 1, 2, 3. Now, we could also run a type on that, and we could see that the data type being held at index 0 is a string, while the type of num period is, I'm sorry, let's do this again. While the data type of num1, because I forgot we did our conversion, is a list. So we have the individual item with a particular data set, and then we have the overarching item with a different data set. So that's cool. Now, let's say we wanted to replace an item, right? So we noticed that with our string of num, we have those spaces in there. And the way strip is working is split is replacing them with nothing, and it is splitting by those characters, which is why we have one item that's 1, 2, 3. We have another item that's 3, 4, 5, 6. The space that was in between them split, utilized, and removed. And we have another item of 7, 8, 9. And these couple of spaces here are removed as well. Now, let's say we wanted to change this around a little bit and bring this stuff back together. So we could utilize something like this. We can give a string of a dash. We can utilize join, and what we're going to join together are the items that we're going to split. Cool. So let's talk through this. We have what we're joining, or our normal string. We're utilizing join, and what we're going to be joined together are the numbers that are going to be split based upon empty strings, those spaces. And when we join it back together, those 3 individual items, we're utilizing this dash as the thing that's going to be the new separator between them. because num.split by itself is going to return 3 unique items. When we join it together, we're saying, what are we going to separate them by? So if we don't like the minus sign, instead we wanted to bring them back together with a plus sign, we could do that as well. Okay, so that's cool. Now, let's say we wanted to utilize split from a different fashion. We'll specify something like birth month. We'll then allow a person to put in the birth month, or rather, we'll just type it in ourselves, and we'll do something like January. All right, and we'll store that as a string. We'll also do birthday, and there we'll store that as a string as well, and we'll say it's going to be the 13th. And we'll do birth year. We'll do a 4-digit year. We'll do that as a string. We'll do 1990. We'll also do birth date. And with birth date, we'll just be putting together the birth month, concatenated with the birth day, concatenated with the birth year. And when we do that and we print out birth date, we get something like that. Now, that may not be what we want because that doesn't necessarily look well. So instead, what we'll do is we'll come back, we'll take this whole thing, and we'll add in some white space. And I'll come over here and I'll do the same thing. So now when I look at birth date, we now have at least spaces in there. Okay, well, let's format that and change that a little bit. Okay, we're gonna split them based upon the spaces. So we'll do birth date dot split. We'll do just open and close. That's going to tell it to split based upon the spaces. And now we have 3 individual items. And I'll go ahead and I'll save that as just B, a variable called B. And when I look at how many items are in there, I can utilize the link method, and it tells me there's 3 items in there, which I clearly see there. Now, let's go back in here, and we're going to format this date, and I'll call it format birth date, and we're going to format it with a dash. I'll do dash dot join, and I'm going to specify what I want to feed it, all right, or what I want to join back together. And what I'm going to join back together is going to be stored in the variable B, because we recognize right now B is holding 3 individual items. And when we do that, we then have the data that we're looking for in the format in which we're looking for. And I did double underscores there, not on purpose. Cool. So we now have our date with dashes in it. This is us kind of just manipulating text to really get it the way we want. Now, we could have also came in here and just did a number of other things, maybe a replace. So I'll go back and I'll look at my original stuff of birth date with the spaces in it. And what I'll do is I'll print birth date. I'll replace the empty space with a dash. Let me wrap up my other parentheses here. And we've essentially accomplished the same thing. So we taken text, we manipulated it for what we needed it to be, and then we spit it back out. So let's alter this text a little bit more. And when I say this text, I'm really thinking different text. So I'm going to say a variable of s, and what I'm going to do is I'm going to declare a string. I think Augusta is an awesome place for cyber. And when I print that string, I see the content of it. Now, I want to split it up. I'm going to declare a variable called ss. I'll do s.split, and I'll do open and close paren. That's going to have my string split by spaces. So now when I look at ss, I have 3, 6, 9 items within it. And this is going to be a list. I can tell my list because of my open and close brackets, but if I was unsure, I could utilize type, and I see it's a list. And if I was unsure of my counting, to be able to say that there's 9 items within that list, I could do len and then specify that list or whatever it is. And it tells me that there's 9 in there, so I feel rest assured. Okay, cool. Now, noticing len told me the number of items within the list I had. When I look at s, that's unchanged, and s is a string. So when I look at the length of s, it's going to tell me how many characters are in there. How many characters are in there. And in this case, that's going to be 46, while ss, the list, has 9 items in it. So let's say we want to print out a variation of our string. So we could do there are, we'll do a close there, we'll do a comma, and we can do len ss, and then we'll do another comma, and we'll do items in the list, and then we'll close it up. So I have the string that I'm declaring or calling upon, there are. I am then feeding it the length of ss, which is 9, and then I'm coming behind it with the items in this list, and what we have is another string that prints out there are 9 items in this list. Awesome. Let's say we want to grab the first character within the variable of s. Well, we can do s, and we understand the first item is really index 0. So we could call upon that, and that's going to return I. What if we wanted to do the first item of ss? Well, the first item is going to be index 0, and that's going to return I as well. Well, you may be thinking, well, these kind of look similar in nature. You told me one was a list while the other one was a variable, a string. Well, let's look at it a little bit deeper. We'll go down and we'll pull index 2, and index 2 in our string is going to be a t. While we look at index 2 within our list, and that's going to be the string Augusta. Again, the list contains items while the string itself is measured and based upon the individual character. Let's say we wanted to get the last item within our string of s. Well, we could do -1, and -1 returns back the exclamation mark. What does -1 do for us when we specify our actual list? Well, that's going to get the last item in our list, the last item in our list. So if our list only goes up to, we said 9, what happens when we try to print something beyond that? Well, let's do that. So we'll do ss, and we'll do 99, because we know that doesn't exist. And we get an error telling us list index out of range. Okay, well, that's awesome and interesting, right? So we appreciate that type of error handling. Let's look at what happens when we do it with our string. Cool. It tells us string index out of range, while the previous one was list index out of range, but nonetheless, it is at least helping us. Now, let's say we did something like this, where we called upon S, and then the index that we did was something like len S. That is still out of range. So we're essentially calling upon S, and the index that we want is whatever the length of S is. Whatever the length of S is. So in that case, the length of S is 46. We were essentially doing that. Now, just because the length is 46 doesn't mean the index ends at 46. Right? This is because, remember, we start at index 0. So really what we want is the length of S minus 1. Because if the number of characters are 46, well, the 46th character is really at index 45, while the first character is at index 0. All right, so we'll come in here and we'll say minus 1, and when we do that, we get the last item. We get the last item. Cool. That is exactly what we wanted to do. Now, let's say we wanted to give it a range. So we could do print, we'll do S, we'll do 0, and then we'll do 35, for example. And we look at what that returns. Right? So it returns, I think Augusta is an awesome place. So this is doing, starting with 0, which is I, and it's going all the way up to the 35th character, but not including it, which is really going up to 34. We recall this when we look at our range. So we're really going 0 to 34 because remember, this last number, it goes 1 minus that. Okay, so let's do something like this where we print S, will then go 0 colon negative 11, for example, and then let's wrap that up and print it. Whoa, so what's going on here? We got the same thing. What this is doing is we're saying, hey, 46 is going to be the length. We're going to subtract 11 from that. So we're doing 11 from the end. And when we do 11 from 46, that puts us at 35. So we're really saying this is 35, and we're going 0 up to 35, but not including it. And cool, that is returning the same thing for us. Okay, so let's do something like Social Security. We'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we'll call it a day. We'll then print Social Security. We get the numbers that we desire. We want to go in here and we want to split it. But what we want to use to split is going to be based upon the dash. Cool. That's going to then split it into 3 items. Now, let's say we didn't want to do the dash. And you may recall where we've been doing open and close paren. Look what we get. We get 1 item returned as a list. Well, why didn't it split it into 3 individual items like we have here? Notice we have a quote and a comma to separate that 1 item. Well, because there is no white space or empty string for us to split by. So it was not split by anything. Okay, awesome. Now, let's say we do something like this, where we did SSN, split, we then did our dash, and then we had index 0. This is going to split it into those items that we talked about up here, and then we're only returning the first one, which is index 0. Let's say we want to return the last one. Well, we recognize that we're going to split it based upon our dash, and then -1 is going to be our last one, and then we return 6, 7, 8, 9. All right, awesome. So that starts to really wrap up our manipulation with strings and what we can do with it. Now let's jump into writing data to a file. All right, so we're going to do that by first understanding the difference between a relative path and an absolute path. So when we look at this, our relative path is going to be, let's write this down, relative, let's do some doc strings here so we don't get formatting all in our way. Absolute path. All right, so relative path is going to start off with our current working directory. Now, we're talking about this in the sense of path connotations within our system. And then absolute path is going to start with the root directory. Think of drive letter, if you will, in Windows, or root in Unix. Okay, so if I had, let's suppose I had a command prompt up, and I see my path right there. But if I said within this path, let's see what I have here. I have a file called desktop.txt. If I gave you the path to it and I said, hey, to run or read whatever you're going to do, I'm going to use the type command just so I can articulate this. If I said, hey, the path to it is cusers wolf.sandbox, and then you can specify the file, all right? This would be our absolute path to it. Because I've given you the full path, and it doesn't matter where you're at on the system, you'd be able to get to it. Now, if I gave you the relative path, it would already assume that you're in the directory that has the file or item you're trying to interact with. And with that, I can just say, hey, dot slash, space dot slash, and then I can specify the item. This only works because I'm currently in the directory that this file is being housed. So I'll come back one, and now when I try to do this same command, the same command with the absolute path, it will still work. When I try to do the other command with the relative path, it does not work. Why? Because within my present directory, my current directory of C users, I do not have that file called desktop.txt. Now, this is a key point because as we look at trying to read files or access files within Python, that same data is important. Also, when we're working with file paths within within Python for Windows, we'll have to do a double slash, and that's because the first slash is going to be escaped, if you will, and then the second one is actually the one that's going to get implied. So this is telling Python, hey, we actually want to put a slash in whatever it is that we're doing. So for us to interact in the fashion that we desire, we're going to be utilizing the OS module within Python. So I'm going to minimize those two screens, and I'll come back here and I'll look at my OS module. So I'll import it in, and then from here I'll look to see what is actually provided to me from the OS module. That's awesome. right? And if I wanted to see the number of items that are now made available to me, I see that we have 152 items that we can utilize. So with this, we're going to do a number of things. And one of the first things that we'll do is we'll look at some features within writing to files. And one of those things is we'll really just highlight what that structure looks like. So the first thing we're going to do is we're going to instantiate an instance of our object, and we're going to have an actual mode that we're going to do it in. So I'm just going to declare FW as my variable that I'm going to do all this in. It doesn't have to be called FW. So I'll do FW open. We'll do something like whatever we want that file name to be. So in this example, I'll just call it file name.txt. And then we'll do a comma, and we're going to specify the mode here. Now, I'm not in an actual Python interpreter, nor do I see myself running this, but I'm really just highlighting what the structure would be. And within the modes that we can use, there's a number of them, but the ones that we're going to focus on are R for read, we'll do W for write, we'll do some RW for read write, A for append. And when we do W for write, it's going to create the file even if it already exists. So if I'm trying to write to the file of file name.txt and it already exists, but I open it in a mode of W, it's going to overwrite the file that I already have there and make a brand new instantiation of it. If I open it in the mode of A for append, if it exists, it will just append within the contents of the file. If it does not exist, it will create the file for me. Awesome. Now, the next thing that I'll look to do is I'll utilize the instance in whichever fashion that I opened it in. So let's say for mode, I did a W here. Now I come down and I can do FW write, and I can specify whatever I want. Now, this doesn't get written to the file just yet. For me to write it to the actual file, I'll need to close it up, and then it will get committed to the file. And really interacting with files are literally 3 steps like so. So step 1, we're going to open the text file in a mode. Step 2, we're going to use the file object, right? We're going to use the file object name that we determined and whatever method that we're using, and then we're going to do something with it. And then step 3, we're going to close the file object rather, utilizing the close method. That's going to actually write the data to the file or close that handle. Okay, so let's do this in actuality, if you will. So first thing I'm going to do is within my newly imported OS module here, I need to figure out where I am. And okay, so let's go ahead and create a file. So we'll do that by making an instantiation. We'll utilize open. We'll give it either the absolute or relative path to where we want to store our file. And in this case, I'll do C. We'll do our double slashes because one's going to get escaped and the other one's going to then be applied as a slash within our string. I'm going to do Windows, we'll do temp, and I'm going to call it test.txt. Now I'll do an underscore, and this is where I give it the mode in which I want to open it in. So I'm going to do W for write. When I do that, I can now do file, or actually, let's do this. Let's do dir on file, and let's look at what we have available to us. We have things like close, encoding, name, mode, write, writable. Right? We have all those good things that we can use. So let's see what happens when we do print file and then mode. That tells us W for write. What happens when we say file dot write a bowl, right? We get really that it's a object, but we want data there. So let's do print file write bowl open close paren, and then we get true. We get that boolean back of sorts. So that's kind of cool, right? That's informative. What if we wanted to know stuff like the name? So we can do file.name, right? And it tells us that that handle that we have open, that this is where it's writing it to. So of our true 3 steps, we've only done one, and that was create the instantiation of it. So now let's do file.write, and we'll say this is a test. And when we look, that's 14 characters, but let's go look at where this is on our system. I'll come in here and I see test.txt. It has a size of 0 kilobytes, but I'll look in there and I see nothing, right? And this is because that data doesn't actually get written until I close that object, right? So now we have 1 kilobyte. We look in there and I see this is just, or this is a test. Awesome. Now, what happens when we do print file write to bowl open close, and we say, hey, IO operation on closed file, like it's not open anymore. Okay, awesome. Now, let's say we wanted to write multi-lines in there. Well, this time I'm going to create my instantiation as F. I'll do open, and I'll do that same path I did before. So I'm just going to come up here and I'm going to copy it. And when we do that, I'm now going to open it in append mode. And I'll say, hey, f.write, and I'll say, this is more stuff. But now I want to do a new line, so I'll do my \n, and then I'll say, and this is also a new line. And I will close that up. We see it's 45 characters. We recognize this doesn't get written until we actually close it. So now that it's closed, we can come over here and look at it, and we see, hey, this is a test. That was our previous stuff. And then we see this is more stuff, and then we did a new line. So notice this just picked up where it left off when we utilized the append. So we would have wanted to have a \n right at the beginning when we open it up. Now, let's say we wanted to rename a file. Right? We have a number of ways to do that. So I see that my item is called test.txt. I now want to rename it. When I look at OS is going to provide me a number of things. One of them is called rename. So what we'll do is OS rename, and we'll come in here and we'll give it the actual path to our file, and then we'll do a comma, and this is about the point where we give it whatever we want to rename it to. So in this case, instead of text, I'll rename it to test.txt. Okay, cool. So when I come in here now and look, text.txt is now test.txt. So utilizing the OS module is very helpful for us. Let's look at some of the other things that we can do. Well, we can do things like get our current working directory as Python knows it. So if we would have did a not absolute path where we specified the full path name. If we would have did a relative path, it would have stored our file right in this directory, because that's what Python knows or thinks knows our system to be currently set at. Let's say we want to change that, so we can do chdir, and then we can feed it the path that we now want to change our current working directory to. So I'm going to change mine to the root of C. I'll do os cwd again, and now it tells me my current working directory is the root of C. Now, right there, let's say I wanted to create a directory. I could do make dir, and I can specify either the full path to where I want to make it, or I can utilize my relative. So I'll make a directory called tempt on the root of my drive. Make dir c : / tempt, close it up, and it tells me it already exists. So let's make a tempt2, and we'll close that up, and now it is there. We didn't get any error. All right, cool. Now, again, I gave it the relative path because I'm already in the C drive. So if I went and looked, I would see that directory there. Now, if I wanted to, we could also do make dir, specify the full path, and be good to go as well. This is largely what we want to do because this leaves nothing to chance. This hard codes in where we want it, and we don't depend on some relative aspects. Now, let's say we wanted to list what's going on in that directory. We could do list dir, and we could specify a directory to list. And this tells me everything that I have in that directory. Now, let's say we needed to see how many items were in there. We could do len os list dir c, and this tells me that I have 44 items in that directory. Awesome. What if we wanted to test if a path actually exists? So we could do os path exists, and then we can feed it a directory or an item to see if it exists. It comes back with true. Let's do the same thing, and we have created all the way up to temp3. Let's look to see if temp4 exists. It comes back and it tells me false. Now, what if I wanted to test if a directory is a directory or not? Well, we can do is dir. That's going to come back with Boolean. We can utilize the same thing, and we can look at files and see if it's a file or not. So os path is file. I'll do C drive again, and it comes back and tell me it is not a file. I can also utilize system commands that I am used to, stuff like ipconfig, who am I, netstats. I can do that right from Python. We utilize os.system and then ipconfig. We got 0. We tried to print it. We got 0 again. Python idle doesn't allow us to return that stuff back to the screen. So for us to go back to the screen, just for us to see it, we'll come over here to the traditional Python interpreter, and then we'll come in here. We'll do os.system ipconfig, and we see that information on the screen. If we wanted to do our actual host name, we see that information as well. Now, let's say we wanted to store it as a variable. We might find ourselves trying something like this for host name. right? But let's look at that behavior. Huh, it just printed the host name to the screen, and then we still have nothing there. So what we need to do instead, and this will work on idle and what idle is looking for, we'll need to do popen. So we'll utilize host, we'll do OS system, open, we'll do host name, and then we'll close that up. And then what we'll do, sorry, not system, popen, and then what we'll do is we'll utilize the read method, and that will indeed store the contents of that to a variable for us. Okay, awesome. Now, let's say we wanted to look at our environment variables. We could do something like OS environ, and we would be able to see them. So when I look at something like WinDir, WinDir is pointed to C Windows. User profile is C users wolf.sandbox. Okay, let's see if we wanted to get information regarding an actual specific item. We could do get env, and then we could specify the one we care about. In this case, I'll do user profile, but I'll do it lowercase. Notice how that worked, and it wasn't a thing that we needed to have it uppercase. If we wanted to do something like get the CPU count, we could do OS CPU count. And sorry, we see that that comes back as a function. And if I want to truly get the count, I'll do open and close on it. And my system currently has one CPU. If I want to see what user is actually logged in, OS get login. And from there, I see Wolf is logged in. Again, if we want the directory list in OS list dir, and I see my directory listing from where I currently sit. If I want to do it for another directory, OS list dir C Windows. Right, I need to specify it within my open and close parentheses. If I want to get my PID, my process ID of my current instance of Python, I could do get PID. All right, so my current instance of Python is running at 4764 is a process ID. What about the parent instance, i.e. the thing that spawned my instance of Python? Well, we could do get ppid, and then we could return that as well. So whatever 3856 is started my instance of Python. Okay, well that's awesome. That's also reassuring as well. Now, if I wanted to print the lines within a file, I would be able to loop through that, but we're going to save that for actual class. So with that, this kind of wraps up what we wanted to get after as far as this lecture. Join me as we talk about Python at another time.